Hello YouTubers and FreeCAD enthusiasts. So I often see on a Facebook group that I'm on, there's a private FreeCAD group that I'm on, and one of the most common types of questions that come up are from new users to the program trying to modify an STL file. Some model that they've downloaded they want to make a change to, and they're trying to do it through FreeCAD. Now, right off the bat, I'm going to say FreeCAD is not the best program for dealing with dense meshes. That said, it is possible in many cases to make simple modifications to an STL file. There's a few tips that I've learned in messing around with them, and I'm going to share some of those with you. Now, this is not going to be the end-all be-all to how to deal with every case of problems you're going to have with an STL file that you're going to run into. I can't cover all of those. But there's some really common things that I can tell you that will help to get you through making simple modifications on many STL files. And so that's what I'm going to try to help you with. Let's go to FreeCAD and let's look at a few cases and how we would deal with them. I'm in FreeCAD version 1.02. I haven't done anything yet. I wanted to talk to you about workbenches, and especially when you're going to be editing STL files. A lot of people in FreeCAD are familiar with the part design workbench. This is a great workbench for creating single solid parts. Here's a project that I worked on not too long ago as a good example. We're looking at one of the bodies. If I bring my model tree down here, you can see I have several bodies in this file. Part design is about creating single solids, one per body. You're designing a single individual part. If we're going to work with STL files, we need to work with multiple solids often. And it's not optimal to work in the part design workbench because this workflow isn't about modifying solids that you import. It's about designing single solid parts. The workbench you probably want to work in if you're going to modify STL files is the part workbench. Now the part workbench has a different set of tools across the top. The part workbench is all about working with individual solids separately from each other. I can easily have multiple solids. I can work with them together. I can use one to cut or add on to another one. Instead of pads or pockets, you would use Boolean operations in the part workbench. So I would take these two and I could use a Boolean union to fuse them together, and now I have a single solid part made out of those two. You can see in the model tree it only shows our fusion. There's still hierarchy. If I hit this little expansion arrow here, you can see under our fusion are the cube and the sphere that we fused together. We could still work with these individually if we wanted to, or modify their dimensions. I could come in here and I could modify the cube's dimensions. And you can see it modified it, but our fusion object is still a single object. So that's the part workflow in a glance, the part workbench in a glance. It's all about working with multiple solids, which is ideal when we're talking about dealing with STL files. So I'm going to stay in the part workbench for the rest of this tutorial. And I have a model opened that I designed recently. It was a set of Morse code paddles, but it's a nice example of FreeCAD's geometry. Now this object consists of lines and little vertices where the lines attach, which you can't quite see there, and faces. The faces might be flat, they might be curved, like this curved face here, but it's fairly simple geometry. Now each of these faces has a name that's kept in memory. FreeCAD keeps its geometry in memory while it's working on it, and that's important in this consideration with STLs. Because we look at a standard FreeCAD object and it's like this curved face is a single face, and if we look down here in the lower left, it'll show us the name of the element that's pre-selected or highlighted. So if I highlight this edge and we look down there, we can see that it says edge 116. This curved face is face number 46. This face over here is face number 33. So FreeCAD keeps track of the geometry in memory by elements, lines, vertices, and faces. And this is a regular FreeCAD object. Let's go and import an STL. and we'll look at the difference. I'm going to go to the part workbench, do a new file, and I'm going to import an STL. Let's take this wheel. This is an RC model wheel, like you might 3D print for your projects. And this is an STL that I downloaded off Thingiverse. Now I'm going to set the draw style here to no shading. So now we can see the edges and faces individually, and you can see right away that an STL model has a lot of geometry. This part of the rim here and this hub, this is a flat face. This should be a single face. In a FreeCAD model, this would be a single face. But when we look at it, you can see it consists of dozens of triangles. All these little individual edges here and faces and vertices, a lot of geometry. And that's because STL is a triangulated mesh. It's a mesh format. And this is the main difference with FreeCAD. In order to work with this object, we have to convert it to a FreeCAD object, and it's going to have thousands and thousands of faces. Maybe tens of thousands, maybe hundreds of thousands if it's a complex enough object. And that is going to slow FreeCAD down. That's why working with STL files in FreeCAD is not optimal. It can be quite slow if your model is complex enough. So let's bring in an STL file that we're going to modify. That RC wheel is probably a good example. Now I have the axis cross turned on. You can see it here. This is showing us the origin point at the center, the x-axis, the y-axis, and the z-axis. And this is handy. When you're designing or modeling things, you want to use that origin point as much as possible for symmetry and centering. And when you import an STL file, it's not guaranteed that it's going to be centered on the origin. So let's go and import our RC wheel. Let's say that we were going to modify this file. So here's our RC wheel, and if I open it, we've imported it, but you can see it is not centered. See that? The axis center point is over here. The center of the wheel is over here. This is the first issue that you might run into with STL files, and I see people asking about this all the time on the Facebook page. How do I move an STL file to the center? Well, it's really easy. Some people might suggest that you transform it to the center, but that doesn't really work that well. It's not that easy to do. If I select transform and I try to move it, I can kind of get it close, and in some cases I might get it dead on. That could be centered. It looks centered. I might be okay in this case, but it could be off a little bit. It's hard to tell. It could be off by 1/10 of a millimeter. It could be off by 1/2 millimeter. Transforming, you're physically moving it and trying to line it up, and that's not guaranteed to get you to the center. Let me show you a way that's much easier. I'm going to select the object. I'm going to right click on it, and I'm going to select placement. Now in the placement dialog over here on the left, there's this checkbox, use center of mass. This is really handy for one main reason here. When I check that, FreeCAD is going to calculate the center of that object. And it has now populated this data up here, X, Y, and Z, with the offset of the center of that object from the center of our 3D space. I'm going to uncheck the box now, and the values remain. So we can see that on X, we are off by negative 16.3 millimeters, 3/10. See, if you were trying to transform it, you probably would have been off by 3/10 unless you really got down there and reduced your movement value. So X was off by 16.3 negative. Y, it's off center by 8.02, 2/100ths of a millimeter. So if you want to be really precise, this is the way we can do it. Now that we've checked that center of mass box and unchecked it, we know how far off we are. We can come over here to the translation side, and we can put in values equal to this but opposite. So this is off by negative 16.3. I'm going to put in 16.3. And you can see the object moved along the X, and it is now centered on X. Y is off by 8.02, so I'm going to put in negative 8.02 to move it in the opposite direction, negative 8.02. And when I tab away, now our object is centered. You can see the axis crosses right in the middle of that center hole. And we know it's precisely centered. If we're going to make changes to it, we can be sure that our changes are going to be accurate now. I don't have to worry about the Z offset. In 3D printing, this XY plane is kind of like the printer bed, so we're sitting right on the bed, so I don't need to center it on Z in this case. And depending upon the object and what you're going to do to it, you might need to center it on Z as well. But that is the easy way to move an STL to the center point. Right-click on it, select Placement, check the Center of Mass box to get your offset values, put opposite values in the translation, and it moves it to the center point. And now our wheel is centered on the origin point. This is super useful for editing later. As you'll see, we're going to make our change. I think I was saying the theoretical thing here is we want to change the diameter of the center shaft hole. Okay, so we have our imported STL in the tree. It has been moved to where we want to move it to. Let's talk about faces. This particular model is not horribly complex. If I change my draw style to no shading, now we can see the polygons. But if we look here, faces on the left here, mesh, faces 6,132. That's not too bad. Most computers and FreeCAD should be able to handle working with an object that complex easy enough. In other cases, you might need to reduce the face count. This is your second tip on dealing with STLs. We want to make sure the mesh is okay, we want to make sure it doesn't have any errors, and we might want to reduce the face count. And we do those things on the mesh workbench. So with it selected here, I'm going to go over to the mesh workbench. Now in the mesh workbench we have a whole bunch of tools specific for dealing with meshes. There's two things here that I'm interested in. One, I want to make sure the mesh is okay, that it doesn't have any errors. So with it selected, I'm going to come up to the Meshes menu, and I'm going to come down to Analyze and Evaluate and Repair Mesh. That brings up this tool over here on the right with a bunch of tests that we can do on the mesh to make sure it's okay. And if I scroll down at the bottom, all above tests together, I'm going to hit Analyze, and this will run all of the tests above. And they finished. And in this model, we're okay. No flipped normals, no duplicate faces, no duplicate points, no non-manifolds, which are holes, no degenerations, no invalid indices, and no self-intersections. On nearly all of these tests, if there are errors, you can hit this repair button and it will repair those problems. The only problem that I have run into in FreeCAD is with self-intersections here, this bottom test. Every time that I have had problems with self-intersections and I have hit repair, it has created holes in the mesh, missing faces. Those were then not able to be detected and fixed by the other tests. So I think there's a bug in the self-intersections segment of this analysis and repair. It might work sometimes, but every time I've tried it, it has ended up with holes in the mesh. So watch out for that. The rest of these, though, you can hit repair if there's errors and it will repair them, and then you can close this tool. So with our mesh fixed, the next thing we need to consider is decimation. In this case, as I said, it's not too complex, 6,132 faces. Ideally, you want to keep the number of faces under 100,000. If you get up even to 100,000 or much higher, subsequent operations in FreeCAD are going to be really slow because it has so much geometry to keep track of. That's why FreeCAD's not really the best choice for messing with meshes, but you can work with them. So watch out for that. If the number of faces are in the hundreds of thousands, you might want to reduce them, and you can do that in here with decimation. So I select my mesh in the tree, come up to the Meshes menu, and I select decimation. And what this will do is it will reduce the number of faces. So if I select absolute number, Right now we've got 6,132 faces. I could reduce it to 3,066, and that would make the mesh less complex and quicker to work with. But you have to think about that too. In this case, we have a lot of curved surfaces here, and if I reduce those meshes, those number of triangles too much, then that'll become very faceted and steppy and flat. You'll see all those little flats. But like I said, in this case, we don't have to really reduce things. But if you're dealing with something that's hundreds of thousands, you want to get it down under 100,000, and you're going to want to watch your curved surfaces. They might get a little bit faceted. But that's the tool that you would use. So pay attention to the number of faces. In this case, we're okay. Try to keep it at 100,000 or less. All right, we're done in the meshes workbench. Let's go and convert the object to something FreeCAD can work with. So we've imported our STL file. We have used the placement options to center it on the origin point. Now we need to convert it into something FreeCAD can work with. Right now it is just a mesh. FreeCAD needs it to be a solid shape. So first we need to convert this mesh data into FreeCAD's mesh data, something that it can understand. And we're going to create a shape. So Part menu, create shape from mesh. This is our first step. So shape just tries to make sure there are no missing faces or holes in the shell of the shape. So we always want to check that. I'll hit OK. And that didn't take too long. Only 6,000 faces. It didn't take very long to do. If this was 100,000 faces, that might take 5 minutes to do. All right. We don't need the original mesh now that we've created a object out of it. So I can highlight that in the tree and delete it. So this is our FreeCAD object. Now it is a shell. And what that means is these solid areas here, like this rib or this spoke that's coming out, isn't solid. In FreeCAD's data, this is just a shell, like an eggshell, and it's hollow inside. We need it to be solid before we can work on it. So with it selected, I'll go again to the Part menu and convert to solid. And again, that didn't take very long, not too many faces. Now we can't delete the original wheel. We might be able to, but this object is dependent upon that object logically, so we have to leave it in the tree. But I'm going to hide it by hitting the space bar on it. And that just leaves us with the solid we just created. The last step we want to do is we want to simplify it somewhat. If we look at it, this hub that should be a single solid face because it's flat is a bunch of triangles. This outer part of the rim, again, a bunch of triangles. It would make it much easier to work on if we could simplify those flat faces to being a single face, and we can by making a refined copy. This is the third step. We take the solid that we've just created, we go to the Part menu, we come down to Create a Copy and Refine Shape. And that refinement is what's going to eliminate some of those extraneous faces for us. This takes the longest. Now with 6,000 faces, it's going to take a few seconds. There we go. It was about 8 seconds. If we had a big model with 100,000, you'd have to be patient because that could take 5 to 10 minutes. That's why you want to reduce those polygons if you can before you work on things. Okay, over in the tree, well, the solid's already hidden. It hid it for us. You can see the eyeball has a slash through it. So we have our refined copy. And if we look at it now, this is the refinement. This flat face is a single face. This flat face is a single face. Everywhere there's curves, it's still triangles. It can't refine those out because of the way it's defined. But flat faces get reduced. Now we can work on this. So let's make our modification. I wanted to make this shaft hole a little bit wider. I think it's 3 millimeters. I want it to be 5, let's say. Well, now I can work on this as a regular object. So I can select this face. See it turn green? I can come up here and do a new sketch on the face. Yep, plain face. Okay. I'm in the sketcher now. And this is where moving this thing to the center was so nice. Now we have a center point that we can use. So I'm going to take the centered circle. And I'll make that 5 millimeters. And there it is. Close. And it's just like modeling in FreeCAD now. In the part workbench, if you were in part design, you might have just gone and hit pocket and pocketed this through. Part workbench, you have to break that down into individual steps. We need to extrude our sketch into a shape, and then we can use the Boolean operation to cut it from the other shape. So I'm going to extrude this cylinder that we just sketched into 3D. And I want it to go negative. I want it to go down. And I think this wheel, I didn't measure it, but I think it's 10 millimeters. So let's just come down here to the extrude data. And let's go negative 15. Should be enough. Negative because I want to go down instead of up. I hit OK. Yep, there's my cylinder I just created. And now I just do a Boolean cut. I select the thing I want to keep, the wheel. Hold down Control and select that extrude. Come up here and do a cut. Normally that would happen very quick, but the inside of that shaft hole had multiple faces, remember. That's the thing with STLs. That's why FreeCAD, you kind of struggle. It has to deal with all that geometry, but there we go. We've made our modification. We now have our wheel with our 5mm shaft hole. I could select it here in the tree, the cut operation, the last thing we did, and go up and export this as an STL, and we will have our modified shape. So that's just an overview of how you work on STLs in FreeCAD, some of the limitations, some of the things you have to deal with, the steps you want to take, and the tricks like positioning. You can hammer in a nail with a wrench if the wrench is big enough, but a hammer is always going to work better. And a program like FreeCAD is not really designed to work with these dense meshes. You can, but it's not its forte. A program that is designed to work with dense meshes is Blender. And a lot of people shy away from Blender because its user interface, when you open it up, just looks incredibly complex and intimidating. But for doing basic edits and simple modifications, it's actually quite capable on working with some of these dense meshes. And I just wanted to show you one example of something you might want to try to modify in FreeCAD and how easy it would be to do in Blender, just to show you how a program that's designed to work with these meshes can do it so much better. Okay, here is another STL that I pulled in. It's a cell phone stand. Now, this is a modification that I saw somebody trying to make on another Facebook page. And they were trying to do it in FreeCAD, and they were a little confused. They wanted to shorten it. So if we look at it from the right, they wanted to shorten this whole thing. Now, you could easily scale it in your slicer. In the slicer, you could just say set the scale to Z 50%, and it would shrink it right down. That might also affect distances on certain things in certain other parts of the model, though, and it would distort certain parts of the model, so it's not really a perfect fix. But anyway, how would you do this in FreeCAD? Well, we could go through the whole process of conversion of this STL into a FreeCAD object, but we're going to have tons of faces. It's going to be slow to work with. And how would you reduce the size of this? You'd be better off just recreating it from scratch, really. It would just be way too much work. You could cut. I suppose you could make a datum plane and cut the model right through here and then right through there, and then bring this back down and try to line them up perfectly and fuse them back together, perhaps. It would be a lot of work. Possible, but maybe not the best tool for the job. It's better to work in a tool that's designed to work with meshes. And I'm going to give you just a real quick example. I know this is a FreeCAD video, but I'm going to give you a real quick example in Blender of how quick and easy it would be to make that modification to this particular STL file. So let's switch over to Blender. This is Blender 5.0, the current version, and I'm going to first import that STL file. So here we are, phone stand. And let's zoom out so we can see it. And here it is. I'm going to go to the side view, and we are going to edit this model. I'll go into edit mode. So now we can see it as a wireframe. You can see all the different faces. especially the geometry around those curves. Look at all those. So a lot of mesh, a lot of triangles here. I'm in edit mode now. I should be able to select elements. Right now I'm in select mode vertex. I'm only selecting the vertices, which is what I want. I can draw a bounding box to select them. You can see them highlight. However, by default, Blender only lets us select what's visible to us. So if I rotate this, you can see I only selected the front faces here, the ones that were visible. I need to turn on X-ray mode, which is this little box here, toggle X-ray. This allows for selecting through items. So now when I select, I'm going to select everything throughout the entirety of the object. So I'll come up here and I'll draw my box. Boom. You can see the fade out down here. It's showing us that we've only got this stuff selected here. And in fact, if I rotate, you can now see we've got the whole thing selected. So toggle X-ray, draw a box. I've selected it. Now I'm going to hit G to grab those vertices. And I'm going to move them down. Just like that. I've shortened it. Oh, now our legs are sticking out too far in the front, so let's select those, grab, and I want to grab them along the y-axis, so I'm only moving in one direction. We'll pull that back in, and there we go. Hit tab to come out of edit mode, and just like that, I have shortened my cell phone stand. 2 quick operations in Blender. It's that easy. Blender's designed to work with these big, complex, and heavy meshes. So it makes it simple to work on these things. There's sculpt items and all kinds of options in Blender. It's really the best tool for modifying STL meshes. If I wanted to put holes in things, I could add a cylinder. I could do a Boolean cut, just like you would do in part in FreeCAD. Very quick and easy, and it has no trouble dealing with huge, complex meshes. So there's just a few tips on how to work with STL files in FreeCAD. Like I said, you're not going to be able to cover every case. There's going to be a lot of things that you just can't really realistically do, and a better tool might be called for. If you are new to the program, new to FreeCAD, and you're just trying to figure it out, just trying to learn it, rather than stumbling through it and frustrating yourself and turning you off to the program, there is a tutorial series that I recommend to everybody that's new to the program. It's done by Darren Stone. It's over on the Mango Jelly YouTube channel. I will put a link in the description below. It's a course that takes you from absolute zero up through modeling, up through more advanced modeling. It's very easy to follow. He runs at a good pace. He covers the right details. I can't recommend it enough. And so, like I said, it'll be linked down in the video description. If you're new to the program, it's worth your time to go to that course and just go through it. Take some time every day or every now and then. Go through a lesson or two, practice, and you'll find that FreeCAD is very easy to work with once you understand how to work with it. Okay, I hope you found this useful, and we'll see you in the next video.
Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.